Which of the following is an example of a vector quantity? To answer this question, you have to remember what is the difference between a scalar and a vector. So a scalar is not dependent upon direction, while the vector, on the other hand, is dependent on direction. So a scalar has no dependency upon what direction, while the vector does have a dependence on the direction. So now if we go through our choices and see which of these conditions it satisfies, we can tell whether it's a scalar or a vector. So a distance. So if we moved around in a circle and came back to the same point, our distance would be the circumference of this circle. We could also move in other weird ways around here that would cover the same distance as if going around the circle, and all of these would give us the same distance. So in all these we're going in different directions, but we're still covering the same distance. So we can see that distance is not dependent on the direction of the path you take, so A is not a vector. B states velocity, so we know that we can have a velocity in this direction for a ball, and we can have a velocity in the opposite direction for the ball. If this was our positive x-axis here, and this was the positive y in the vertical here, we would say that this velocity here would have velocity of positive 5 meters per second, while this velocity pointing the other way would have a velocity of negative 5 meters per second. So here we can see a dependence upon direction in this case. So B, velocity, is a vector. C here is mass. So we know that the mass of the object does not change. So if we have some object here, mass m, if we move it to someplace else, say over here to this position, so this is P1, and we're moving it to P2, that object is going to have the same mass. It's not going to have changed. D states that area. So if we have the area here, which is just length times the width of this box, it's not going to change if we move it to some other direction. If we increase the length by a certain amount and the width by a certain amount, we can still maintain the same area. It's not dependent upon what direction this box is facing. Say this is the top, so if we were to flip it around, put the top down here, that would not change the area. It's not dependent upon which way it is directed, unlike velocity. If you flip the direction the velocity is facing, you're changing its sign. So that's why B, your velocity, is a vector.